So now we are going to discuss collisions. So first we need to understand what is meant by collision. For example, this is the surface of the ground. So one body is moving with some velocity v, and there is another body which is at rest or in motion. Rest or in motion. So but here the velocity of this is less than this one. Then this is making physically or colliding physically the second body, we can call it as collision. Otherwise, for example, when I taken a charged particle plus q, now I am bringing another positive charge toward this positive charge. Then what happened? At a particular point, this positive charge, or this we can take it as unit positive charge, will experience some force. That force is nothing but F is equal to q into E. So this is the electric field developed by this one. Because of the electric field developed by the positive charge, this charge will experience a force. Because of the reason, it will repelled by the source charge, or we can take it as positive charge. Now that means the path of the one is affected by the another. So collision we may consider a collision is said to be done when one body is physically colliding with another body, or the path of the one is affected by the force experiences or the force expended by the particle. So that is called we can call it as collision. Okay. So write the definition of the collision. A collision is said to occur a collision is said to occur between two bodies either if they collide physically, or the path of the one body is affected by force exerted by another body. Force exerted by another body. So that means, so in this case, the collision is said to occur between if they physically collide, against each other, or the path of the one body is affected by the another body which is experiences or which is exerting some force. So this is also we can consider as collision. So this type of collision occurs in the case of charges. So you know, in the case of Rutherford experiment, so positively charged ion, that means we can take an atom, it is a positive nucleus. When alpha particle is taken, alpha particle is nothing but helium 2 plus ion. This is positive ion. When this particle is projected and it is coming toward this atom, because of this positive charge, and this is also positive charge, there is a repulsive force. So up to some extent, up to some distance only, this alpha particle can come. So after that, it will comes back to its original position. That means there is a repulsive force. This is known as a distance of closest approach. So this again we'll discuss in the chapter of atoms. That means the path of the alpha particle is affected by the force exerted by the positive nucleus. Positive nucleus. So up to some extent only the particle can go. After that, the path of the alpha particle is reversed. This is a scattering angle of 180 degree. So even though there is no physically contact between the two particles or the two bodies, the path of the one is affected by the another. That is also can be considered as collision. So that is the point we need to consider. So if the collision physically collide against each other, or the path of the one is affected by the another, so that can be also can be called as collision between the two bodies. So that is the basic definition of the collision.
Yes, sir.
Right. Next, there are the following types of collisions. First one, elastic collision, or we can take it as perfectly elastic collision. Both are same. Simply elastic collision or perfectly elastic collision. Second one, inelastic collision. Inelastic collision. Next one, perfectly inelastic collision. Perfectly inelastic collision. And fourth one, super elastic collision. Elastic collision or perfectly elastic collision. You see, elastic collision or perfectly elastic collision, both are same. But inelastic collision, perfectly inelastic collisions are different. So while discussion of those two separately, we can get clarity. What is the difference between inelastic collision and perfectly inelastic collision? So elastic collision or perfectly elastic collision, both are same. Inelastic collision, perfectly elastic collisions are different. Then super elastic collision. This is one type classification. And also based on the motion of the bodies after and before the collisions, we can call it as collisions in one dimension and collision in two dimensions. So that means elastic collision in one dimension, elastic collision in two dimensions. The same way, all types of collisions we can consider based on the before and after the collision, the state of the motion of the bodies. We can say one dimensional collision or two dimensional collision. Okay. Now, now put a heading. First one, elastic collision. If there is no loss of kinetic energy during collision, there is no loss of energy, loss of kinetic energy during collision is known as elastic collision. So here, no loss of kinetic energy, no no loss of kinetic energy. Okay. Now,
Yes, sir.
so characteristics of elastic collision. Point A, momentum, that we can call it as linear momentum. Linear momentum is conserved. linear momentum is conserved. Total energy is conserved. So during elastic collision, linear momentum is conserved, total energy is conserved. Conservation of energy. Energy can neither be created nor destroyed, but it can be transferred, or it can be converted into one form to the another form. So in the same way, linear momentum is conserved, total energy is conserved, and kinetic energy, kinetic energy is also conserved. So this is an important point you need to observe in the case of elastic collision. So this is the reason we are saying if there is no loss of kinetic energy during the collision, that is called elastic collision. So this is the difference when you are comparing other type of collisions and elastic collision. So in elastic collision, kinetic energy is also conserved. Next. Forces involving forces involving during collision are conservative forces. Conservative forces. So this is conservative forces. So what are the forces involving during the collisions are conservative forces. What is conservative force? The work done by the force does not depend on path followed by the body. It depends only on initial and final point of a body is
Final
known as,
points.
or final positions of a body is known as conservative
Conservative.
force. So forces involved during the elastic collisions are conservative forces. And kinetic energy. Kinetic energy is not converted. Kinetic energy is not converted into other forms of energy. Kinetic energy is not converted into other forms of energy like heat, light, sound. So because kinetic energy is conserved. So kinetic energy is also conserved during elastic collision. So kinetic energy is not converted into other forms of energy like heat, light, and sound. So in practice, when you're observing this elastic collision, after the collision, there is no generation of heat energy, there is no generation of light, so there is no generation of sound. For example, when you are taken two billiard balls, that means elastic or subatomic particles collision. These two are colliding with each other, but we can't observe heat energy, we can't observe light, even we can't observe sound also. So that type of collision is known as elastic collision. So in practice, in practical, what are the collisions are taking place? So those are all not elastic collisions, because there is a collision between two bodies means at least we can able to observe the sound. So sound is also not coming because of collision between the two bodies. That type of collision is known as elastic collision. So normal in daily life, what are the collisions are occurring? At least sound will come. So because of that reason, all are inelastic collisions, not elastic collisions. So collisions between two glass balls, or collisions between billiard balls, or the collision between subatomic particles may considered as elastic collision. That means even because of that collision, there is no generation of sound. So the main important points related to this elastic collisions are momentum is conserved, total energy is conserved, kinetic energy is also conserved. This is the special point related to elastic collision. So forces involved during the collision are conservative force. So what type of forces are involving during elastic collisions or conservative forces? Okay. So kinetic energy is not converted into other forms of energy like heat, light, and sound. That is the first type of elastic collision. Second one, inelastic collision. Inelastic collision. If there is a loss of kinetic energy during collision, if there is a loss, there is a loss of kinetic energy. There is a loss of kinetic energy. There is no loss of kinetic energy is elastic collision. There is a loss of kinetic energy is known as inelastic collision.
Yes, sir.
Now, characteristics. Point A. Linear momentum. Linear momentum is conserved. Linear momentum is conserved. Point B. Total energy is conserved, but kinetic energy is not conserved. Kinetic energy is not conserved. So this is the difference between elastic and inelastic collision. So kinetic energy is not conserved. Forces involving during collision are non-conservative forces. Non-conservative forces. In the case of elastic collisions, conservative forces. In the case of inelastic collision, non-conservative forces. Kinetic energy is converted into other forms of energy like kinetic energy converted into other forms of energy like light, heat, sound, etc. That means when there is inelastic collision between the two bodies, we can observe the generation of light, generation of heat, and generation of sound. For example, when we are taking two balls and colliding with each other, sound will come. Sound will come. So when we are taking collision between two vehicles, so sound will come. So because of that, fire will come. There is heat energy and light energy also will come. So practically, what are the collisions we are observing in nature? So they are all are inelastic collision. So here kinetic energy is converted into other forms of energy. Next, third one, perfectly inelastic collision. Perfectly inelastic collision. So this is the most important one related to collisions. Perfectly inelastic collision. So many times the given question from this concept in the NEET examination as well as JEE mains examination. So what is a perfectly inelastic collision? After after striking or after collision, two bodies stick together. After collision, the two bodies stick together, stick together and may at rest or moving with moving with a common velocity. Moving with a common velocity is known as perfectly inelastic collision. So what is the point we need to observe here is, in the case of perfectly inelastic collision, after the collision, the two bodies stick together and may at rest or moving with a common velocity. So we can see the example. For example, when you take in wet sand and throwing on the wall, throwing on the wall, then what happens? This wet sand will stick to the wall. Now it is in the state of rest. Now this collision. Because of this collision, what happened? At least the sound will come. So because of this is inelastic collision. So in that inelastic, the special category is perfectly inelastic collision. So in the case of perfect inelastic collision, after the collision, the two bodies stick together. They may be at rest or moving with uniform velocity. So this is one example. Otherwise, we are taking a wooden block which is placed at rest on the ground. Now we fired a bullet into this wooden block with velocity u. Velocity u. After the collision, this block is embedded. Block is embedded inside the block, and the combined system is moving with some velocity v. This is called common velocity for both of them. So after collision, this bullet is embedded inside the wooden block, and the entire system is moving with a common velocity. So this is also an example for perfectly inelastic collision. So this is the most important application of perfectly inelastic collision. So after collision, the two bodies stick together. They may be at a state of rest or moving with a common velocity. That collision is known as perfectly inelastic collision. So these are the examples. Okay, so as usual, what are the points given for an inelastic collision, characteristics of an elastic collision? So those may be valid for this also, because momentum is conserved, total energy is conserved, kinetic energy is not conserved, forces involving are non-conservative forces, and kinetic energy is converted into other forms of energy. The difference between the two is, in the case of perfect elastic collision, perfectly inelastic collision, there is a condition after collision, the two bodies are stick together and moving with a common velocity. Okay. Right.
Yes, sir.
Fourth one, super elastic collision. Super elastic collision. After collision, kinetic energy kinetic energy sharply increases. Sharply or suddenly increases. Sharply or suddenly increases. Then the type of collision is known as superelastic collision. There is an example: explosion of bombs. explosion of bombs or crackers. Bursting of crackers are example of superelastic collision. Okay, so these are the four types of collisions: elastic collision, elastic collision, inelastic collision. Elastic collision or perfectly elastic collision, both are same. Inelastic collision, third one perfectly inelastic collision, superelastic collision.
Okay, sir.
There is the classification of or types of different types of collisions. Now we'll go with the elastic collision. Elastic collision in one dimension. Elastic collision in one dimension. Right. So one dimension means before and after the collision, the two bodies are moving along a straight line path in the same direction. So this they are called one dimensional collision, moving along same straight line path. Now, we can take an example. This is ground or surface of the earth. Now we can consider two balls. This is one ball is moving with velocity u, having mass m1. It is moving with velocity u1. Another body, another body of mass m2 moving with velocity u2. Now these are moving like this. Here u1 should be greater than u2. So this is the condition. This is the condition for collision happen between the two bodies, because if u1 is moving faster, u2 is going slower, then only we may expect a collision between the two bodies. If u2 is greater means this body can't reach this body, then there is no collision between these two bodies. Now here we are considering physically colliding between each other. The type of collision we are discussing now. So here to occur collision between these two bodies, u1 must be greater than u2. U1 must be greater than u2. So these are moving with different velocities. Now this is the situation before collision. Before collision. Now, so what is the momentum of this body? P1 is equal to m1 u1. This momentum is P2 is equal to m2 u2. What is kinetic energy of first body? Ke1 is equal to half m1 u1 square. Ke2 is equal to half m2 u2 square. Half m2 u2 square. So this is the situation before collision. So momentum of first body is m1 u1. Momentum of second body is m2 u2. Kinetic energy of first body is half m1 u1 square. Kinetic energy of second body is half m2 u2 square. This is the situation before collision. If this condition is satisfied, that means u1 is greater than u2. Then there is a collision between the two bodies. Now, these two bodies are colliding with each other for some time. Sometime they are colliding with each other. So this is the condition of during collision. This is the situation of during collision. During collision. So very less time there is a collision between the two bodies. After that, what happened? First body, for example, second body. Second body is moving with the velocity of v2 of mass m2. Now, so first body is moving with velocity of v1 of mass m1. Now, what is the momentum of this body? This is the situation of after the collision. After the collision. So, what is momentum of first body after the collision is m1 v1. Second body p2 is equal to m2 v2. m2 v2. As usual, kinetic energy ke1 after collision is half m1 v1 square. This is ke2 is equal to half m2 v2 square. So these are the kinetic energies after the collision. You see here again there will be a condition. There will be a condition. These two bodies are striking with each other or colliding with each other for some time. Some time. So after that, what happened? This first body is moving away from this. Second body is moving away from the first body. To go away from this body, this velocity must be greater than velocity of the first body. That means here v2 must be greater than v1. Then only there is a separation between the two bodies. So see, this is the body having velocity u1. This is the body velocity u2. So this body can approach the second body. First body can approach the second body only when u1 velocity is greater than u2 velocity. u2 velocity. So during collision, sometimes there is a collision between these two bodies. After that, this second body is separating from the first body. So to separate this second body, this velocity must be greater than this velocity. Then only it will go away from this body. So this is separation. So this will happen. So after collision, this situation will happen only when V2 is greater than V1. V2 is greater than V1. Now in general, we'll say one body, one body is moving with velocity 30 km/h. Another body is moving with velocity 50 km/h with the same in the same direction. So which is faster? Second one is faster. How much faster? That is 50 minus 30. That is equal to 20 km/h. That means 20 km/h. First second body is faster than first body. Or 30 minus 50 minus 20, which means first body is 20 km/h slower than the second body. So this is the situation we can understand by seeing the two bodies are in motion. In the same way, when first body is moving with velocity u1, second body is moving with velocity u2, with what velocity this first body is approaching this one is nothing but u1 minus u2. u1 minus u2. So that is known as relative velocity of approach. Relative velocity of approach is equal to u1 minus u2. u1 minus u2. So this we need to understand by that example. So this is going with velocity e1. That is, for example, this is 50 km/h. This is moving with velocity 30 km/h. Now, with what velocity this first body is approaching the second body is nothing but 50 minus 30. That is equal to 20 km/h. So with 20 km/h velocity, this body is approaching the second body. So that is known as relative velocity of approach. That will be equal to u1 minus u2. In the same way, when these two bodies are moving with velocity v1 and v2, so this is moving with velocity v2. It is separated. So what is the relative velocity of separation? So here greater velocity is v2. Greater velocity is v2. That means relative velocity of separation. Relative velocity. Relative velocity of separation is equal to v2 minus v1. So these are the key points to understand elastic collision. So relative
Okay,
velocity
sir.
of approach is u1 minus u2 because u1 is greater than u2. Relative velocity of separation is v2 minus v1 because v2 is greater. Now, for an elastic collision, elastic collision, relative velocity of relative velocity of approach is equal to relative velocity of separation. So why we are taking like this? Because kinetic energy is also conserved. There is no loss of kinetic energy. That means there is no loss of velocity. So with what velocity the first body is approaches, with the same velocity the second body is separated from the first body, because there is no loss of kinetic energy during elastic collision. So that is the reason we can take directly u1 minus u1 minus u2 is equal to v2 minus v1. We can take a modulus magnitude. So theoretically, we can understand relative velocity of approach is equal to relative velocity of separation because there is no loss of kinetic energy. Otherwise, so according to conservation principle, total momentum is conserved. So what is the total momentum? Total momentum before collision is equal to total momentum after the collision. Total momentum before collision m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is equation number 1. So during characteristics of elastic collision, we said first point is linear momentum is conserved. So m1 v1 plus m2 v2 is equal to m1 v1 plus m2 v2. And kinetic energy is also conserved. Momentum, first one, half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. That is equation number. So by simplifying these two equations, finally you will get this expression, that is u1 minus u2 is equal to v2 minus u. So there is a derivation for this, and again we need to do the derivation, and we need to get this expression from these two equations. No need to derive the expression of this one from this, because directly from the concept we can understand relative velocity of approach is equal to relative velocity of separation, which means with what velocity the two bodies are approaching, with the same velocity the two bodies are separating from each other, because there is no loss of
Separated.
energy, because kinetic energy during elastic collision is conserved. So from that we can take this is v1 minus v2 is equal to v2 minus v1. Now after collision we can derive the expression for velocities by using this one. So then those expressions for solving numericals related to objective questions, we need to write those expressions without going this derivation and all. We can write the expressions. Now velocities, velocities of bodies after the collision, velocities of the bodies after the collision. Now is it completed? Okay. So velocities of bodies after the collision, we can take v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. This is velocity of first body after the collision. Velocity of first body after the collision. Next, velocity of second body after the collision. We need to replace 1 and 2. So are replacing 1 and 2. That means m2 minus m1 by addition means we can take like this. M2 minus M1 by M1 plus M2 into U2 plus 2M1 by M1 plus M2 into U1. So we need to remember this V1 expression. Then from this we can write replacing 1 with 2. We can get second body velocity after the collision. So V1 and V2 are velocities after the collision. After the okay. Note down these expressions. Velocity of first body after the collision is v1. Velocity of second body after the collision is v2. So v1 expression alone we need to remember. So based on that v1 expression, 1 is replaced by 2. You will get 1 is replaced by 2 and 1 and 2 are exchanging. Then you will get second expression. That means velocity of the second body after the collision. After the collision. Now, now we'll see some cases related to this. Case 1. Case if m1 is equal to m2 is equal to m, the two bodies having equal masses. Equal masses. So then after the collision, what is the velocities? What are the velocities after the collision? So m1 is equal to m2 is equal to m. That means m minus m, so it will become 0. 2m by m plus m. 2m, 2m cancel will be equal to u2. That means v1 is equal to u2. v1 is equal to u2. Okay. Right. v2 is equal to, this will term will be equal to 0. This is 2m by 2m. 2m cancel. This is equal to u1. So v2 is equal to u1. It is equal to u1. So from this we can observe what is u2? Velocity of second body, velocity of second body before collision. That means velocity of first body after collision is equal to velocity of second body before collision. This is velocity of second body, velocity of second body after collision is equal to velocity of first body before collision. That means bodies exchanged their velocities. Body exchange their velocity. So based on this, simply we will ask the numerical. So simply we need to write. So velocities are interchanging. Exchanging of velocity will use velocities after the collision. This is case 1 when equal masses are colliding with each other. Next, case 2. If m1 is equal to m2 is equal to m and u2 is equal to 0. That means second body at rest. Second body at rest. That means equal mass. Equal masses of two bodies are colliding, but second body is at rest. Which means we can take this is one body of mass m is moving with velocity u. This is of second body of mass, same mass, which is at rest. Then what happened? So v1 is equal to you see v1 expression, you see v1 expression. So m1 minus m. So this term will be equal to 0. And again u2 is equal to 0. This term is also 0. That means v1 is equal to 0. v1 is equal to 0, comma v2 is equal to, what is v2? we can go with m minus m. This term will be equal to 0. This is m plus m, 2m. 2m to m cancel. This is equal to u1. Is equal to u1. Now we can write v2 is equal to u1. V2 is equal to, which means after the collision, first body comes to the state of rest. Second body is moving with velocity of the first body. Velocity of the first body. So that means after collision, after the collision, after the collision, first body comes to rest. First body comes to rest. And second body, second body moving with velocity, moving with velocity of velocity of first body, velocity of first body before collision. So u1 is velocity of first body before collision. That means first body completely transfer the energy to the second body. So first body is coming to the rest. Second body is moving with velocity of first body. That means completely exchange of kinetic energy. So they will ask the question like this. During the collision, the first body completely exchanges energy to the second body. Second body. So what is the relation between their masses? So their masses are equal. So second body is at rest, masses are equal means the first body completely exchanges with mass to the kinetic energy to the second body. Okay. So theoretically, they will ask the question while solving the numericals. Uh, what is the use of these points? What we are discussing now? These cases and all we will get while solving the numericals. You can get an idea how we used those concepts earlierly you studied and helpful to solve the numericals. Okay. This is case 2.
Okay, sir.
Case 3. If m1 is greater than m2. M1 is greater than M2. You see, what is V1? V1 is equal to M1 is greater than M2 means MT, M2 should be neglected. That means in the place of M2 we need to take it as 0. Okay. So here M1 is greater than M2, or we can take U2 is equal to 0 also. Second body is at rest. Very small, very small mass at rest we have placed. That situation is very big mass, very big mass of mass m1 is moving with velocity u or u1. So second body is very small body of mass m2, negligible mass, which is at rest, which is at a rest. This is the situation of consideration of mathematical conditions like this. Okay. So now v1 is equal to what is v1? M1 minus m2. So m1 minus m2 0 by m1 into what is u1. So m1 cancel. This is u1 plus u2 is equal to 0. That means v1 is equal to u1. v1 is equal to u1. Now what is v2? v2 is, you see v2 is equal to m2 0 minus m1 by m2 0 minus u2. v2 is equal to minus u. So u2 is equal to 0. Then this term will be equal to 0. Now here m1, m2 is neglected. So m1 cancel 2 into u1. That means we can take v2 is equal to 2 u1. 2 u1. That means v1 is equal to u1, v2 is equal to 2u2. So from this we can say what happened? There is no change in velocity of a first body. After the collision also, velocity is the same. Velocity is the same. But second body is moving with, second body is very small one. So second body is moving with a velocity which is double of first body velocity. First body velocity, because very less mass, by striking this one, so this is moving with double the velocity, this is moving with velocity v2, which is equal to double the velocity of first body. But there is no change in the value, there is no change in the velocity of this first body. So first body as usual it is moving. So even though it transfers some of energy because of second body mass is very less. The second body very less massive particle is moving with double of its first body velocity when m1 is greater than m2. First body is moving with its initial velocity, but second body is moving with double of its double of velocity of the first body because very less mass. Right. Next case 4. If m2 is greater than m1, that means second body is very heavier body and which is at rest, which is at rest. Now what is v1? V1 is equal to m1 minus m2. We'll go here. Ah, m2 is greater, m1 is negligible. So m1 is 0, m1 is 0, m2, this is m2. That means minus e1, minus e1. So u2 is equal to 0. That means this entire term will be equal to 0. So we can write v1 is equal to minus e1. v1 is equal to minus e1. So what about v2? v2 is equal to, see v2, so m2, m1, m2 is greater, m2 is greater. So u2 is equal to 0. This term will be equal to 0. Now this is m1 is neglected. When you are comparing, m1 is neglected. That means v2 is equal to, v2 is equal to m2 is greater than m1. So m1 is 0, then this term will be equal to 0. So v2 is equal to 0. What it means? It means first body is very small one. Second body is very big one. By colliding this, what happen? It will comes back. Will comes back in any direction based on the angle of colliding the body. So minus e1. So the velocity of this body, that means it is comes back with the same velocity, the same velocity. Because of this very small body colliding heavier body does not changes its state. Still it is in the state of rest. Still it is in the state of rest.
Yes, sir.
So when m2 is greater than m1, first body comes back with the same velocity, comes back is represented by negative sign. So second body, as initially it is in the state of rest, the body will continue in its state of rest because very small body is colliding that heavier body. Then there is no change in state of that body. Okay. So this is about
Okay, sir.
elastic collision in one dimension. Okay. So is it okay, ma?
Yes, sir.
No. So in this elastic collision in one dimension, very important application is there. Okay. What is that application? Two bodies are, you can consider like this: a body of mass m1, You note down a body of mass m1 moving with velocity, u1 makes a collision, with a body of mass m2, which is at rest, That means u2 is equal to 0. u2 is equal to 0. So the situation is looking like this. So this is of mass m1 is moving with velocity u1. So this is another body of mass m2 which is at rest. So this is the situation we need to consider. So first body is moving with the velocity u1, second body is at rest. Now, so what is the momentum of first body is m1 u1. What is momentum of second body? 0. Right? Next, kinetic energy. Kinetic energy of first body is half m1 u1 square. Kinetic energy of second body ke2 is equal to 0. So this is the situation of before collision. Now write the important points regarding this the situation. First one. First point. Velocity of first body after the collision. Velocity of first body after the collision. What is velocity? V1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. As u2 is equal to 0, this entire term will be equal to 0. So m1 minus m2 by m1 plus m2 into u1. So this is v1 is equal to m1 minus m2 by m1 plus m2 into u1. This is velocity of first body after the collision. So velocity of first body after the collision is v1 is equal to m1 minus m2 by m1 plus m2 into v1. Next, second point. Velocity of second body after the collision. Velocity of second body after the collision. See, what is the expression for velocity? V2 is equal to m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1. As second body is at rest, this term will be equal to 0. This term will 2m1 by m1 plus m2 into u1. So v2 is equal to 2m1 by m1 plus m2 into u1. This is equation number 2. That is velocity of second body after the collision. velocity of second body after the collision.
Okay.
Next point. So this is very important point because based on these points they ask the question in the NEET examination. Right. See, first body is moving with velocity, second body is at rest, which means it has some velocity, so it has some kinetic energy. So it doesn't have any kinetic energy. This is the situation before collision. After the collision, second body is also having some velocity. This is this much. That means the second body is taking some energy, is taken some energy from the first body. So we can write kinetic energy of first body after collision. Here, terminology is very important. So we need to identify based on the terminology. We need to solve the numerical. Kinetic energy of first body after the collision, or kinetic energy retained by a first body. Kinetic energy retained by the first body. So initially, kinetic energy of the first body is known as total kinetic energy of the system, because only first body having kinetic energy. After the collision, the sum of the kinetic energy is transferred to the second body. Because of that, the how much kinetic energy is retained. That means sum of the energy is transferred to the second body means, so only sum of kinetic energy is only retained by the first body. So this is known as kinetic energy of first body after the collision, or kinetic energy retained by the first body. Now we can write, so kinetic energy retained. So this terminology they will ask in the question. They will give in the question what is the kinetic energy retained by the first body. So kinetic energy retained by the first body is nothing but kinetic energy of first body after the collision. So after the collision we can write half m1 v1 square. This is equal to half m1 into what is v1? V1 value we already did, right? M1 minus M2 by M1 plus M2 into V1. So M1 minus M2 by M1 plus M2 into U1. This is V1 square. So V1 is M1 minus M2 by M1 plus M2 into U1. So here V1 square. So this whole square. That implies kinetic energy retained by first body be equal to half M1 U1 square. So from this expression we can write half half m1, this is e1, so half m1 e1 square into m1 minus m2 by m1 plus n2 into 1 square, m1 minus m2 by m1 plus m2 into 1 square into 1 square. Now you see what is half m1 e1 square? What is half m1 e1 square? Kinetic energy of a first body before collision. So this we can take it as total energy before collision, because only first body having kinetic energy before collision. So kinetic energy of the first body we may call it as total energy. Total energy. So that means we can write so kinetic energy retained by first body by total kinetic energy, or we can take it as initial kinetic energy, is equal to m1 minus m2 by m1 plus m2 into whole square. This is equal to fraction of fraction of kinetic energy retained by retained by first body fraction. Kinetic energy retained by first body is kinetic. So this is initial kinetic energy that we can take it as total kinetic energy. Fraction of kinetic energy retained by the first body. So what is the kinetic energy retained by first body, or what is the fraction of kinetic energy retained by the first body, or what is the percent retained energy by the first body is nothing but into 100 into 100. So while solving the numericals, we will get the importance of this one. So we need to remember this m1 minus m2 by m1 plus m2 into whole square is the fraction of kinetic energy retained by the first body. Okay, this is
Okay, sir.
that is point 3. Right. Next point 4. Kinetic energy of second body after the collision. Kinetic energy of second body after the collision. So before collision, kinetic energy of second body is 0. After collision, it is getting some kinetic energy. From where it is getting? Because energy can neither be created nor destroyed. It can be converted into one form to the another form. That means kinetic energy of the first body is only transferred to the second body. So that is the reason we can say kinetic energy of the second body after the collision, or kinetic energy kinetic energy transferred to the second body. Kinetic energy transferred to the second body, or kinetic energy lost by first body. So what is the kinetic energy lost by first body? That is only transferred to the second body. That is only kinetic energy of the second body after the collision. So here terminology is important. So in some while asking question, they will use a different terminology. So there, kinetic energy retained by the first body, kinetic energy transferred to the second body, transferred to the second. So what is the loss of kinetic energy of first body is only transferred to the second body. That is only kinetic energy of the second body after the collision. After the collision. Now, terminologies we need to identify. Later we can write the expression kinetic energy transferred. So this is a terminology they will use in most of the numericals. Kinetic energy transfer is equal to half m2 v2 square. This is equal to half m2 into what is v2? You see here, what is v2? 2m1 by m1 plus m2 into u1. 2m1 2m1 by m1 plus m2 into u1 whole square. 1 by m2, 2m1 by m1 plus m2 into u1 is the v2 whole square. Now, kinetic energy transferred with as half m2 4 m1 square u1 square by m1 plus m2 whole square. m1 plus m2 whole square. It implies kinetic energy transferred will be equal to half m1 m1 u1 square into 4 4 m1 m1 m2 by m1 plus m2. We can rewrite this equation like this. Here, half m2 m1 square. So this from m1 square m1, this u1 square here written like this. So 4m1 remains 4m1 into m2. So 4m1 m2 by m1 plus m2. Now here, this is initial kinetic energy or total kinetic energy before collision. So we can write this kinetic energy transferred to the second body is initial kinetic energy into 4m1 m2 by m1 plus m2. It will be whole square is there. Yes. So here 4m1 m2 by m1 plus m2 whole square. 4m1 m2 by m1 plus m2 whole square. So here also m1 plus m2 whole square. Whole square. Now fraction of transferred kinetic energy will be equal to 4m1 m2 by m1 plus m2 whole square. This is fraction of kinetic energy transfer. Transfer to the second body. Percentage means into 100. I will show once you can write now. So kinetic energy of second body after collision. So kinetic energy is transferred to the second body or kinetic energy lost by the first body.